So layer block sounds like a powerful technology. Can you reflect any on what change it's meant to people as they're confronted with developing a new application? Do they think about the architecting of it now any differently than they did in the past?
Certainly when we build new instances of the forecaster, right, it changes dramatically how we think about configuring that, because now there's a lot more structure in place based on the existence of layer blocks itself and these assembly specifications to allow us to plan for a new configuration of this capability and to divvy up the parts when executing it. In terms of new capabilities, I think it's been a mixed bag in the sense of I think that people often find it very difficult to come up with the right abstractions initially. So even with layer blocks and with this approach kind of in the bag of tools, we often don't immediately think when we have a new problem to solve that it's going to be a product line, right? Or that this is the right way to solve it. And I don't know what to do about that. Perhaps if we got better at kind of a priori feature analysis, it would be more obvious. Or perhaps maybe you have to build one or two products, you know, in a product line to recognize that you have a product line there to begin with. I'm not really sure. I think it's still kind of an open question. But that's been our experience to date.
The other thing I'd like to ask you is for the benefit of the students who might want to become software architects. Do you have any reflection on the relationship between kind of the academic knowledge that you learn about software design, software architecture, and what you have to confront in the real world with doing software architecture?
So let me think of a few things that it's all over the map. I've found that in the last 7 years I've used just about everything that I've learned in a software engineering course that at the time seemed very abstract and perhaps I thought I'd never use this. I do. But let me try to be concrete about things I've found that are definitely useful skills. So maybe the biggest one for me is, well, two. One is data modeling, be it data modeling using ER or ORM or UML or whatever, getting really good at modeling at a conceptual level, the structure of data in a system. If you're going to build any kind of system like the ones I'm just mentioning, that is a really critical skill. And even though it's taught pretty well in database courses, and a lot of people take database courses, you'd be amazed at just how rare it is to be really good at that. So getting facility in data modeling, and not applying it just to database design, but to any kind of information design problem at all, I found it extremely useful and to really pay dividends. I've also found it really useful to get really comfortable with many different models of software composition, because you just never know when one might be useful, and they often are. So when I was a student at Georgia Tech, I spent a lot of time learning how to use process algebras, and you know, CSP, FSP, Lodos. There's a whole family of these action languages that were very interesting to me, and we covered them in classes, and we learned how to use them, and they had very nice compositional capabilities that were very elegant and very clean and were very well studied, but it wasn't really clear how to use them. You know, in something, there was not a compiler that you would write programs in this language to use to build a big piece of your system. But over time, I've found that they come back a lot. In fact, we've started using them in logic blocks as the basis for building a batch automation framework, where you've got this problem of designing workflows, and you have to compose them, and you need to compose them using a small number of very clearly defined operators and doing it cleanly and being able to reason about it. So things like that have been very useful. Petri Nets, which I studied many, many years ago, and also seemed like a nice, elegant way to think about concurrency and data flows and workflows. Again, it's not immediately obvious how to just take that and use it, but you'll find that they'll inspire designs that you'll see in the future, and they'll be just the right thing when you run into some architectural problem. What are some others? Any kind of algebraic approach to thinking about software composition. I think that maybe is the underlying theme. If you can if you can understand nice, clean, elegant models of software composition, what are their properties, when are they useful, how can you use them to inspire designs, you'll find that a lot of infrastructure work that you do tends to be better by having been inspired by these ideas that have been worked out by a lot of very smart people over many years, rather than trying to come up with it yourself. And I guess maybe the last thing I'd say is a segue from that, and that is this is not something that we tend to do very well generally as software developers, but knowing a body of related work, and when you start a new problem, try to relate your problem to a problem that's already been seen, because chances are someone has solved it or solved some variant of it that you can heavily borrow from. I think that's huge, and I think that that's maybe the biggest piece of advice I would give to a budding software architect.
So what I'm hearing is the world is filled with all kinds of complex problems, and the more weapons you can bring to bear to solving them, the more likely you are to be able to get a handle on that complexity.
Indeed, indeed.
Well, Kurt, this has been a wonderful wonderful story you have to tell about this, and I'm glad that you were able to apply some of your academic background to solving it. And I just want to thank you very much for conveying that story to the class.
You're very welcome, and thank you for the opportunity to tell the story.